So test the convergence of the series. That is summation n is equal to 1 to infinity x power n by n power n. This term contains x raised to n. We use ratio test. So for ratio test we need un and un plus 1. So what is un? The terms inside this summation is we taken as un. So un is equal to x raised to n by n raised to n. So un plus 1 is equal to, what is un plus 1? Un plus 1 is equal to, replace n by n plus 1, that is n plus 1 by n plus 1 whole power n plus 1. Now limit n tends to infinity, un plus 1 by un is equal to, you write this one, that is limit n tends to infinity, x power n plus 1 by n plus 1 whole power n plus 1 into n power n by x raised to n. You multiply with the reciprocal of un. So that is n raised to n by x raised to n. Here x raised to n will be cancelled. So here only one x remaining and here no other chance to cancel. So what is the remaining term? Only x. This n plus 1 whole power n plus 1 can be written as n plus 1 whole power n into 1 by n plus 1. So that is limit n tends to infinity, n power n by n plus 1 power n remaining 1 by n plus 1. These two terms, both numerator and denominator have this power n. So we can write in a single term, that is n by n plus 1 whole power n. Now you take n as common inside only. So that is n into, here no n term, that means 1 by n. So that n and n cancel, we can get 1 plus 1 by 1 plus 1 by n whole power n into this value 1 by n plus 1. When you, this is equal to what? This is equal to e only. In the denominator we will get e. How will you get e? So this can be written as 1 by, that is 1 by 1 plus 1 by n whole power n. Its reciprocal term is in the numerator. Also the limit is n tends to infinity. This become e. So that is in the denominator it is e, that is 1 by e. But as n tends to infinity, 1 by infinity is equal to 0. Therefore the given series converges. This is equal to 0 and less than 1. So the given series converges by ratio test. So this is the answer. Now let us do one more problem, that is test the convergence of the series 1 by 1 into 2 into 3 plus 3 by 2 into 3 into 4 plus 5 by 3 into 4 into 5 plus etc. So this here the nth term un is not given. Okay, nth term un is not given. So that can be calculated from this given series as, so that is the first numerator is 1, 3, 5 etc. So numerator is 1, 3, 5. So what is 1, 3, 5? 1, 3, 5 etc. means this is a AP because common difference is fully 2 only. So A equal to 1, D equal to 2. Then we can apply the formula A plus n minus 1 into D. So by using this trick we can find this value. Now what about the denominator? The denominator you take this way. First term is 1. Here the first term is 1. Here the first term is 1. So we take 1, 2, 3 etc. That is equal to, first term is 1, second term is 2, third term is 3, means nth term is n only. So n only the nth term of first term of the nth term. Now second term is 2, 3, 4. So if here 1, here 2 means next term is n plus 1. So nth term is n plus 1. That is equal to n plus 1. Now the third term, that is 3, 4, 5. So if here n means next one is n plus 1, the next one is n plus 2. So that is n plus 2. So in this way you can find the nth term of the given series. So that is only here numerator, first term is 1, 3, 5 etc. in the numerator. So by using a plus n minus 1 into d, we can get nth term is equal to 2n minus 1. What about the denominator? So that is first term 1, 2, 3, etc. First term is 1, second term is 2, etc. Then nth term is n only. What about the second one? 2, 3, 4, etc. First term is 2, that is 1 plus 1. So last term is what? N into, not n plus 1. Now here one more added, that is n, then this is n plus 1, this is n plus 2. So nth term is n plus 2. Therefore the nth term is of the form numerator 2n minus 1, first term n, second term n plus 1, third term n plus 2. So this contains fully polynomial of n. If this contains fully polynomial of n, we can use only this comparison test, limit comparison test. So what is limit comparison test? For limit comparison test, we have to find a term which to compare. That term is the highest power term in the numerator, that is equal to n only. Don't take the coefficients. Then the highest power term of the denominator. So here n into n, total n cube. That is why Vn is equal to n by n cube, that is equal to 1 by n square. Now for ratio test, we use the formula limit n tends to infinity un by Vn. Then limit n tends to infinity n square into 2n minus 1 by n into n plus 1 into 2n n plus 2. Because when you divide by un, so divide un by Vn, we take the reciprocal multiplication. So this n square goes to numerator. That is n square into 2n minus 1 by n into n plus 1 into n plus 2. Now you take the common factor of from the numerator, we can take n cube. From the denominator, we can take n cube cancel. We can get 2 minus 1 by n. Here 1 plus 1 by n, 1 plus 2 by n. Applying the limit, what is the value? This value is equal to 0, that is 2. This value is 0, this value is 0. That is 2 greater than 0 is finite. So since this is greater than 0, the given this un and vn converges or diverges together. So now we can find the value of what? This convergence of, find the convergence of Vn. So what is Vn? 1 by n square. By p test, if p is greater than 1, then the given series converges. That means 2 is greater than 1, Vn is convergent. If Vn convergent, by limit comparison test, the given series converges. So here this word limit is important. There is two tests. One is comparison test, another is limit comparison test. Here we use the limit comparison test only. So by limit comparison test, the given series converges. So this is the answer. Thank you.